Section 13.2 is on probability with permutations and combinations. Recall that probability is the ratio of the number of favorable outcomes to the total number of possible outcomes. In other words, probability is what I want, my favorable outcomes, divided by all of the possible outcomes, or in other words, what's possible. What I want divided by what's possible. A permutation is an arrangement of objects in which order is important. Let's take a look at an example here. So 4 friends are lined up for a photograph, and how many different ways can they be positioned? So in the first spot, you have 4 choices of people. So in other words, any one of those persons could be in the first position. Okay? And then he is standing there. He or she is standing there. In your second spot, well, you've already got one person placed in the first spot, so now you have 3 choices because one has already been placed. Then for the third spot, you have 2 choices left. And for the fourth spot, you only have 1 choice. So if you recall from the fundamental counting principle, the total possible of number arrangements is 4 choices for the first spot, times 3 choices for the second spot, times 2 choices for the third spot, times 1 choice for the fourth spot, or a total of 24 possible arrangements. So there are 24 different ways that 4 people can line up for the picture. So this product, 4 times 3 times 2 times 1, can also be written as 4 with an exclamation point after it, which is called 4 factorial. So the definition of that, n factorial, is the product of positive integers less than or equal to n. So n factorial would be n times n minus 1 times n minus 2 times n minus 3, so on until you get down to 2 times 1. So for example, 6 factorial is 6 times 5 times 4 times 3 times 2 times 1, which is 720. And for larger numbers, you don't actually have to sit and punch all of those numbers into your calculator. On your calculator, if you hit the math button, go over to the probability menu, down to number 4, you'll see the factorial sign. So you put in your number. Let's say you want to do 6 factorial, so type 6, go to math, probability, down to 4, enter, and then enter again, and it'll give you 6 factorial is equal to 720. And you'll notice that 0 factorial is just defined to equal 1. That's something that they just decided that's what it's going to be. Here's another example. Eli and Maria are among 30 contestants in a talent show. If contestants are called at random to perform, what is the probability that Eli is chosen first and then Maria is chosen second? Okay, so the probability of Eli being first and then Maria second is going to be 28 factorial over 30 factorial, which if you plug that into your calculator comes out to be 1 over 870. So how did we get that? 28 factorial represents the number of possible arrangements after Eli and Maria are chosen first and second. So let me write that out for you. The number of possible arrangements after Eli and Maria are chosen. So out of your 30 people, let's say Eli is chosen first, so you've got 29 left, and then Maria is chosen second, you've got 28 left. So you've got 28 people left to fill the 28 possible spots. And 30 factorial represents the number of total possible arrangements because there were originally 30 contestants altogether. So that's the number of total possible arrangements. And this is a probability problem because what I want is Eli chosen first and Maria chosen second. So the probability of that happening is 28 factorial over the total possible. And because there are 30 contestants, 30 factorial is what's possible there, the total possible. So suppose you have a group of 6 friends, but only 4 are able to be photographed at a time. The number of possible arrangements can be calculated using the permutation formula. That is, the number of n objects taken r at a time is given by this formula right here. A subscript n, an uppercase P, and a subscript r. That is equal to n factorial divided by the quantity n minus r factorial. And it works out like this. So if I were to have a total of 6 friends, and I needed to choose 4 to be photographed, I would write that as 6p4, so that would be 6 factorial, because that's my n, over 6 minus 4 factorial, because that's n minus r, or 6 factorial over 2 factorial. You can actually write it all out, 6 times 5 times 4 times 3 times 2 times 1, over 2 times 1. Notice that the 2's will cancel out, the 1's will cancel out, and you're left with 6 times 5 times 4 times 3, or 360 possible ways to do that. You can also do this in your calculator. Take a look at the math menu, and you'll see that it's possible to calculate a permutation in this way. Here's an example. An ID card contains 4 digits chosen from the digits 0 through 9, and digits are not repeated. First of all, how many possible ID cards are there? So there are 10 total digits, and it's going to be a permutation, and I'm going to choose 4 of them. So plugging that into my calculator, I get 5,040. Second part of this question, what is the probability of a card's number being 4213? Well, of all of the possible combinations of numbers, there is only one combination that is 4213. So the probability of that is 1 over 5,040. Remember, what I want is 4213. There's only one of those possible out of a total of 5,040 possible. Another way to look at permutations is permutations that have repetition. So the number of permutations of n objects in which one is repeated r sub 1 times and another is repeated r sub 2 times, and you could have another repeated r sub 3 times, and so on, is given by this formula. N factorial over r sub 1 factorial times r sub 2 factorial times r sub 3 factorial, however many you have, all the way up to r sub k factorial, where k is your last one. Let's take a look at an example that uses this. What is the probability that a 7-digit phone number with the digits 5, 6, 1, 5, 2, 1, and 5 is actually arranged to be the number 5565211? Okay, so in this case my n is going to be equal to 7 because I have a total of 7 digits. So that's going to be, 7 possible digits, so that's going to go on the top of my fraction. That's my n factorial. And because the number 5 appears 3 times, that's going to be 3 factorial. So 5 appears 3 times. And because the number 1 appears twice, that's going to be a 2 factorial. And none of my other digits are repeated. I only have also a 6 and then a 2. Nothing else is repeated. So plugging that into my calculator, I get that there are 420 possible answers there, or 420 possible arrangements. So the probability of the number being in order 5565211, there's only one way that can be arranged. So that's going to be 1 out of 420. A combination is an arrangement in which order is not important. The order in which things are arranged is not really important. So the number of combinations of n objects taken r at a time is defined as subscript n, capital C, subscript r, and that's equal to n factorial over the quantity n minus r factorial times r factorial. This one you can also do on your calculator. And here's an example. A set of alphabet tiles are placed in a bag. What is the probability that A, E, I, O, and U will be chosen randomly from the bag? So in the bag we have 26 tiles, and we're going to be choosing 5 of them, okay? And there's only one chance that I could choose each one of those. So plugging that into my calculator, that probability is 1 out of 65,780. There are 65,780 different ways I can choose 5 tiles out of there. There is only one way in which I might choose an A, E, I, O, or a U. So, to sum up, we've reviewed the concepts of permutation and combination that you would have learned about last year in Algebra 1, and now introduce the idea of using probability. And a lot of this is you're able to do on your calculator, but please take the time and show the steps for all of your work.